Okay, so today we are doing the graphing part of the assignment. So yesterday we did what was highlighted in red, which was we solved each inequality. Today we're going to do what's highlighted in purple, which is we're going to graph the solution. Okay, so we got some solution. Now today we're going to come back and graph it. This is what you need to write down as far as your notes. Okay, open or close circle. You have to decide that first. And the way you decide it is your inequality sign. If it's a less than or greater than with no line underneath it, it's an open circle. If it has a line underneath it, meaning or equal to, then it is a closed circle or a closed point. And then the second thing you have to do is you have to either shade to the left or shade to the right based on your solution, or based on basically which direction your inequality sign is pointing, which is why it's important to remember the flipping the sign thing, because if you forget to flip the sign, you'll shade the wrong side. Yes. Yep, whatever you want. Okay, so does anybody need me to wait a second on going on so you can get this written down? Okay, I'll wait a sec, because I do want you guys to have this written down. Yeah, hopefully it's review, because I know you guys did do this yesterday. It's always nice when we hit something that's review, because it's just like a mental break. It's like, ah, yes, I remember this. And then after we're done with the notes, I'll pass out the cookies I brought for everybody here today. Chocolate chip. All right, are we good? Okay, so graphing, honestly, the reason I said this was going to be a quick 5-minute video, graphing is super easy if you already have it solved, and it's really easy if you have it written in the right order. Because remember I said that these two right here were the same thing. When we solved it, our variable was on the right. I said that's not ideal, because when you go to graph it, you want to read it. And if I'm reading this one right here, it's all ends less than or equal to 2. Very easy to graph in this way. If you're trying to do it this way, you actually have to read it backwards. You have to say all ends. You got to recognize that because the small part is pointing toward the end, this is actually a less than or equal to, even though it looks like a greater than, because we're used to seeing a greater than with the opening on the left. But because the variable's on the right, it switches the meaning, which is why I don't like leaving it like this. So you have to read this backwards and say all ends less than or equal to 2. This is all ends less than or equal to 2. So these two are exact. This one is just easier to graph. Okay, so that's why I say if you get a solution that looks like this, spin the whole problem. Okay, this is not flipping the sign, because we kept n as less than, we still have n as less than. Okay, yes. We're going to get to that. Okay, all right, so on number 1, are we going to have an open or a closed circle? Closed. We're going to have a closed circle. The reason is because of this right here. It has a line underneath it, so that tells us we're going to have a closed circle. And the number or the solution tells us where to put that closed circle. So on the number line, we're going to put a closed circle on 2. And what's really nice about when your solution is written in the right order, your line or your shading is going to go the same direction as your inequality sign. So if you'll notice, my inequality sign is pointing this way. That tells me I need to shade. I'll try to do it in a different color so it shows up better. That means I need to shade this way with an arrow, because everything including 2, everything less than 2 and including 2 is a solution to this inequality. Meaning if I were to plug 0 into that inequality, I would get a true statement. If I tried to plug 7, which is greater than 2, into the inequality, I would get an untrue statement. It would not work as a solution. Okay. And what's nice about this, like I said, is that if your inequality is pointing backwards, your line should be, your line should be pointing backwards. Okay. So if it's written in the right way, shading is super, super easy. Okay. So number 3, we've already solved it. So open or close circle over -120. Anybody? Open. So we're going to put an open circle over 120, and then our inequality is pointing backwards, so our shading needs to go backwards. Your arrows should match if you have it written in the proper order like this. Okay, and this is why I said I didn't really want you to leave it like that, is because that is very difficult to graph. Okay, you kind of have to flip your mind and think through it a little bit harder than what you need to. All right, number 5, open or closed over -2. Anybody? Open. So over the -2, I'm going to put an open because this is just a greater than. And my arrow is pointing forward, so my shading needs to go forward, and my arrow needs to go forward. Notice I'm putting an arrow because it's unending in that direction. It's everything, not in this one, it's not including -2. So I can't use -2 as a solution, but anything greater than -2 works. And I always like to remember the open circle is like a bubble that protects -2 from the solution because it's not included, okay? So anything greater than -2 is a solution to this inequality. So always put an arrow on your line because everything forever and eternity going forward is a solution, okay? All right, number 7, we worked this one and we got x is less than 1. So open or closed over 1. Open. And my arrow is pointing backwards. So my shading is going to go backwards with an arrow. Arrows should be pointing in the same direction if your equation is, or your inequality is written right. And it's because it's all x's less than 1. And we shaded all the x's on the number line that are less than 1. So it makes sense. Okay. All right, number 9, after we did all the work, we got a no solution because -10 is not greater than -5. That's untrue, right? So it's no solution. If you think about what graphing is, it's shading every number on the number line that is a solution. Do we have anything to shade? Nope, so the graph is done. Okay, there is no graph for a no solution because there is nothing to shade because there's not a single number on the number line that makes this true. Okay? So that graph's done like that. All right. Kind of the flip side of that is when you have an infinite. Infinite means every single number on the number line forever and ever both ways is a solution. So you, whoops, it's jumping around on me. You shade the whole number line and you put an arrow going back and an arrow going front. I said that backwards. An arrow going back and an arrow going front. Arrows in both directions because all real numbers. Another way you might see infinite, and I guess I should tell everybody this just in case you see it on an iReady or on a Savvis. Infinite, the other way you might see it is all real numbers. That means the same thing. I just like less words, so I usually put infinite, but it means the same thing. So all real numbers means every single number on the number line going left, going right, forever and ever both ways. Okay? And that's it. That is shading, or that is graphing. So on your even ones, we've already checked that your solutions are right. So now just graph your 5 solutions and you're done with your homework for today. Okay? All right, for everybody that's doing this at home, make sure that you, if you do it on Cami, make sure you submit it. If you have any questions, shoot me an email.